Hello, this video is covering surface brightnesses and their calculation, and the learning goals will be to first understand what surface brightness means and what it is composed of, and then we will also try to practice this a little bit in this video, and I will also refer to the HeartQula app where there are more examples to do the practical exercises for it. Excuse me, here's an object, the sun is radiating, and this object reflects, emits and transmits. So we have emitted radiation due to the object temperature. Sunlight here, for example, may be transmitted through, and there may be some radiation coming from somewhere else which is going to be reflected. So the surface brightness here is the total radiation flux of a surface. So it's a sum of reflection, transmission and emission. And the example would be here this window pane. Now the surface brightness of this object of the right hand side is then made of emission, reflection and transmission. And these three then make the surface brightness, which then would be detected as infrared radiation by such an infrared camera. If you remember, in the first video I showed you this image where the infrared camera, which is picturing itself here, also takes a reflection of the person that took a standard photo. And if we are asked to determine the temperature of the the surface of object 1, only the emitted radiation would have to be taken into account. So reflected and transmitted are kind of disturbing this measurement. Now the next object we look at here is one that does not transmit, it just reflects and emits. So we've reflected and emitted radiation. Again, sum of reflection and emission make the surface brightness. The example could be a rigid body of steel or concrete or wood, and the surface brightness then is just composed of two entries, that's emission and reflection. If we take a black body, there would be no transmission, no reflection, just pure emission. Then in this case, that could be a cavity, we have the surface brightness being just the emission. Now let's have a look what happens if we have more radiation sources. So we have again the sun, reflected radiation, emitted, and another source like environment, the ambient or whatever, and could come radiation from lights in a room and so on. So there's additional reflection. So again, surface brightness would be let me go here to take that off. All of this is surface brightness. That's surface brightness. So from all radiation sources has to be taken into account. Now, if we have specific spectral characteristics, for example, a reflectivity that is showing two levels, or transmissivity the same, emissivity be constant. In this case, it would be a natural choice to make two areas that would be number 1 and number 2, and then look at this independently. And take the laser pointer. Then we would divide the incident radiation into the two regions. Region 1 from 0 to lambda 1, region 2 from lambda 1 to larger wavelengths or up to infinity, as shown here mathematically. And in the spectral view, he's showing Planck's curve, intensity over wavelengths. It would be short wave and long wave regions that we would split up here. And how do we now calculate the surface brightness? Well, we take everything into account, and at the end we will do a separate consideration of the two wavelength regions and then do a superposition afterwards. So in each region we would take all the contributions into account, and for the surface brightness of the object at the end would superpose all of that. Now let's do some examples. In the HeartQula app, I'll show you first what the symbols mean. Here, for example, there's an illustration of the task. There's a question that says what needs to be determined. So that's the surface brightness of that object in the center. We have an input keyboard for putting the formulas in, and there are some symbols, and this symbol would mean a black body only emission, a gray body that has emission and reflection, a gray body allowing also transmission, and a gray body allowing emission, reflection and transmission. And with all that, let's move forward to solve one task. And important that emission is always there, because our objects typically have a temperature which is larger than 0 Kelvin. Now here we have to determine the surface brightness of this object, a black body which is just emitting. So we only consider own emission. This means reflection and transmission are gone, and then it's just A1 epsilon 1 sigma T1 by the power of 4. As we know that's a black body, we could also take this epsilon 1 out, and it's just A1 sigma times T1 by the power of 4. Do not forget the area to be put in here. So that's the black body. Now let's have a look at an enclosed body. Object 1 shows reflection, object 2 also allows transmission, and both are gray objects. So we consider own emission and reflection, and this means transmission is not there for Q.1, surface brightness of object 1, and this is now the part that is emission plus reflection. And what is reflected? Well, that's the surface brightness from this own object times the view factor phi11 plus the view factor for radiation from object 2 to 1 times surface brightness of 2. All that together is being reflected. Now, besides emission, there's the reflection part in here, and what we also have to take into account is here, we'll take another color. No, not green. Green is going to show up. Let's take orange. Q.2 is going to be needed for determining Q.1 as well. So we have also to formulate surface brightness of 2. And 2 shows transmission and reflection, so we have a rho and a tau in there. Well, what's transmitted? That's all what's coming from 1 times the view factor from 1 to 2. And what's being reflected? That's also, again, everything that comes from 1 times this is view factor phi1, 2 times Q.1, and here it's being reflected, so times rho 2. And all of that is then going to be inserted here to finally receive Q.1. So you see, it's important to systematically set this up. So please work exactly as shown here. First write down what is contributing, emission and reflection. Then formulate the corresponding terms. And also do not forget to put the view factors in. As those can be a little bit complicated, I would consult you to always put them here as a placeholder and define them separately. So do not put the solution for the view factor into the equation here, just write it down separately so the term is then defined. And you see there's an implicit setting up of surface brightness, because the surface brightness for 1 contains surface brightness of 2 and vice versa. So these two are interconnected. Now let's move on to a more complicated example. And in this more complicated example, we have here a transparent object as indicated, and we have to consider the right hand side. So emission and transmission are considered there. And now let's determine the surface brightness, for example, of this object or of this object. The first one, Q dot, sorry, there's a mistake. I need to just, this should be Q.3 on the right hand side. So Q.3 on the right hand side contains emission, and no reflection, because row 3 is 0, it's not indicated, but contains transmission. So as shown above, emission and transmission are there, and here's the formulation for the terms. The surface brightness of object 1 is a black body, it's just emitting, that's written down here, and for the sake of completeness, the surface brightness of 2 is containing emission and a reflection term as indicated by the little symbol here. Note, if just the surface brightness of this one is being asked, we could stop after equation 1 and defining the corresponding view factor here that's needed. If we need to determine all the surface brightnesses, then Q dot 1 and Q dot 2 are needed there as well. And again, Q dot 3R is to be inserted here finally to get the final solution. This brings me to our comprehension questions. So you should be able to answer the question how the surface brightness can be interpreted physically. Then you should be able to name the principles which are observed when we set up the surface brightness, and as I indicated by the camera, have a look at how can we measure infrared radiation to determine surface temperature, and there you need to know which part of the surface brightness this information is carrying. Thanks for listening.